Hello everyone, I welcome you all to Startup Academy, India's only exclusive coaching for ISS examination. In the previous lecture, we did some of the numerical analysis topics. In today's lecture, we'll move forward to a new topic in which I will tell you about some of the new operators. We have learned about forward operator. This triangle is known as forward operator. And the inverse of this triangle is known as backward operator. We all know what are their functions, and if you don't, and this is your first class, then you can go back to the first class of numerical analysis and watch that. Today we'll start with the new operator, which is shift operator. What is shift operator? It is represented by the letter capital E. Now, if I say that I am writing E of fx, then this would be equal to fx plus 1. Here we consider the power of E as the addition term of x in the function. So here the power of E is 1, and hence comes our term fx plus 1. If I say E square of fx, then you all know this, then it would be fx plus 2, because the power of E is 2, so here we'll add 2. If we say what is E raised to the power 3 by 2 fx, then this would be equal to fx plus 3 by 2, and so on. Whatever the power of E is, that will be added in the function with x. This is known as shift operator. Now moving forward to another Shepherd's operators. There are two operators of Shepherd's. One is represented by mu and the other is represented by delta. Now what is delta fx? If I say, then it is nothing but fx plus half minus fx minus half. This is our delta function or delta Shepherd operator, as we called it. And if I say mu, then this is the average of these two operators. So the average of operator fx plus half plus fx minus half upon 2 is the Shepherd's mu operator. These are the two very important operators which have been regularly asked in our examination. From our examination point of view, it is very important. Now, what are the relationship between delta and mu, Shepherd's operator mu? If we say that we are writing Shepherd operator fx, then we can also write it as fx plus half minus fx minus half, right? So this can be written as e raised to the power half of fx, and this can be written as shift operator raised to the power minus half of fx. If we take fx common, then this would be e raised to the power half minus e raised to the power minus half of fx. And if we take e raised to the power half also common, minus half also common, then we would be left with e minus 1 fx. And e minus 1, we know that for a function 1 plus delta is equals to e. This is one of the important relationship between delta and the shift operator, forward operator and the backward operator. So e minus 1 would be nothing but delta. So it would be e raised to the power minus half delta fx. And hence we get our relation delta equals to e raised to the power minus half delta. This is our relationship between delta and delta, the Shepherd's delta and the forward operator. Now, if we have to find out the relationship between backward operator, which is inverse of triangle or delta, and Shepherd's operator, then we know that Shepherd of fx can be written as or instead of this we can write delta of fx can be written as fx minus fx minus 1. Here fx minus 1 can be written as fx minus e raised to the power minus 1 fx. And if we take fx common, then we are left with 1 minus e raised to the power minus 1 fx. And if we multiply both the sides with e raised to the power half, if I multiply it, e raised to the power half fx e raised to the power half, then it would be e raised to the power half minus e raised to the power minus half into fx. And hence our derivation would be, this is nothing, e raised to the power half minus e raised to the power minus half. If we see here clearly, this equation e raised to the power half into e raised to the power minus half should be equal to our delta, Shepherd's delta. So here we can write it as e raised to the power 1 by 2 delta fx. Sorry, it is inverse delta fx, and this can be written as delta, and we can write e raised to the power half the forward operator, and hence we get one more relation between delta and this. And there is one more relation between both of them. If we say mu, then we can write it as e raised to the power half plus e raised to the power minus half upon 2 into fx. Fx and fx get cancelled. Let us focus on the operators only. So instead of writing, we can say that taking square on both sides, we can say that e raised to the power half plus e raised to the power minus half whole square upon 4. Now this whole square can be written as e plus e raised to the power minus 1 plus 2. If I add and subtract 2 from here, subtract 2 and add 2 and upon 4. If I do this thing over here, then we can also write this as e raised to the power half plus e raised to the power minus half whole raised to the power 2, and instead of plus here we can say that it could be written as minus, and we can write it as 4. So what have I done here is e plus e raised to the power minus 1 minus 2. I have taken this and I have added 4, and this can be written as e raised to the power half plus e raised to the power minus half whole raised to the power 2. Right? We can write it like this, and whole upon 4. Now this term, as I've told you earlier, is nothing but delta. So I can write it as delta square upon 4 plus 1, 4 upon 4, which is equals to mu square. And hence we get one more relation between delta and mu, which is mu square is equals to delta square upon 4 plus 1. No derivation will be required in the examination. You just have to mug up the exact exact relationships between them. Just I am doing derivation so that if any question in the examination comes of that kind, you can solve it in seconds. Like I am solving it. So in the last derivation, I would just tell you what are the relationships between delta, forward operator and backward operator. So it would be delta square by 2 plus under root of delta mu, and here it would be minus delta square by 2 plus delta mu, and delta square by 2 will remain as it is, but delta and mu, I can write it as delta and mu can be written as under root of delta square by 4 plus 1. Since we have calculated, mu will be under root of this because this is the derivation of mu square. So I have just written that. And here also we can write minus delta square by 2 plus delta into under root of delta square by 4 plus 1. These two also has to be learnt and no derivation is required for them. Okay. Now let us begin solving the questions that has been asked in your PYQs. So first is this question. What are the delta and mu are the central differences? They are also known as Shepherd difference and central difference, and average operators respectively. Mu and delta is equals to. So we have to calculate mu and delta. Now mu multiplied by delta. Now we know that this uh, what have we done? This delta and delta, because in the option we have been given the forward and backward operators. So we know that the relation between delta and mu and sigma is delta square by 2 minus plus delta into mu. I can just write mu here, right? This is our equation number 1. If you know the result, then only you can solve the question, otherwise you wouldn't be able to solve the question by any method. So, and the inverse of delta, that is the backward operator, is minus delta upon 2 plus delta mu, which is our second equation. So if we add both these equations, then this is forward plus backward. This is plus and minus with the same will get cancelled, and this is 2 times of delta mu, and hence we get delta mu is equals to delta plus inverse operator upon 2, and which is our answer? This. It was this much easy. I am explaining you, that is why I am taking in more time. If I would have been doing it and known these two concepts, then I would have solved it within the seconds. So this is your answer. Let's move to the next question. Now this we did in the first class. As you remember, I have told you a relation. They ask you direct relations of these operators. So direct relations are very important for your exam point of view. And they tell you that we have to subtract forward backward from forward, and the answer will get, first is forward, then the answer will be forward, and the second is backward, then the answer is backward. I can tell you the derivation also, but there is no requirement of the derivation. You just have to mug up this, and this question in particular has been asked many a times in your examination. So your answer will be part B. Now they have been given us the following, which is correct. Now they have given us equal to sign. First of all, we know that delta mu is, we know that E is equals to 1 plus delta. So E minus delta will be equal to 1, and here the sign is equal to. but here we have been provided with not equal to this, and hence this is our correct answer, because in the last one it is not equal to 1, which is false. We have to find the correct answer. So if I subtracted delta minus e, then this will also be subtracted and it will be minus 1, which is not equal to 1, and hence it is true. Then the fourth question goes on like this. Now these are the properties of E. First of all, e raised to the power n should be equal to 1 plus delta raised to the power n. Because we know that e is nothing but 1 plus delta, we have just replaced this. So this is correct. The second is e follows the properties of exponential, and exponential property is given as n plus m fx. So the second one is also correct. Third one is delta also follow the properties of exponential. So it is also correct. Delta of m plus m fx. Fourth one is also correct. Now talking about e square x square. If we take e square of x square, then it would be equal to x plus 2 whole square, because we are just adding the power of e in the function. So it would be x square plus 4 plus 4x, right? And if we take the LHS, right hand side, e of x would be x plus 1, and its whole square will be x plus 1 whole square, which is not equal to LHS, and hence this is wrong. So our answer would be only 3 expressions are correct. And the last question. This question has directly been given from the formulas, the direct relationships, and we know that mu square is equals to delta square by 4 plus 1. So mu would be, if I have to consider mu, then square will get cancelled and it will be under root. So first relationship is correct. Then we know that delta is nothing but delta square by 2 plus delta into mu, which is 1 plus delta square by 4. So second is also correct. And if we have to see the third one, which is delta square by 2 minus plus delta under root 1 plus delta square by 4. Here if we see that here mu is absent, so this is wrong, and only two expressions are correct, which is our option number B. And that completes your PYQs. Within seconds we have done the PYQs only if we know the concept and the formulas. In these kind of questions, you just need to know the relationships among them, and you will just see and solve them within seconds. So numerical analysis is a very important topic, and it comes for 20 questions comes in the first examination, statistics paper 1 of numerical analysis, and each question is of 2.5 marks. So you can estimate its importance in the examination. You cannot leave this topic. If you have not understood anything, then you can ask in the comment section or our WhatsApp channel. Only relevant doubts will be answered. And this was all for today's lecture video. All the best. Thank you.